Okay, now let's get into practical aspect of the GPIO on STM32 microcontroller. So let's start with a new project. So I'm gonna go to File, New, and then STM32 project. And we need to wait a bit. Okay, so now we just go for board selector, and then we choose STM32 F407 G disk 1. Okay, so now we just choose the board, but this time, sorry, just the project name GPIO. Yeah, GPIO project. Then finish. And the thing is that we don't want to initialize all the peripherals. So I press no here. We wait for the initialization to begin and to end. Okay. Okay, so we have the basic configuration of the pins, and as you can see, like these pins are already assigned, but they are not initialized. So the difference is that the pins are assigned to uh, to the microcontroller, but they are not initialized. It means that they are not configured. So, for example, the USB is not configured, the debugging port is not configured. So that's the only difference, and that would help us. So for now, I want to start with the LEDs. Okay, so in this example, the LEDs are already configured for us. Okay, so what I want to do is that I want to disable all of them and put them in reset mode, and then we will go through again and configure them again. Just for I will do this only as a demonstration. You can just skip this, okay? But I would suggest that you do the same. So I will click on the PD12, and then just choose reset state. Okay, reset state for all of them. Okay, so that's it. Now that I just put those pins as reset, so they are not connected to anywhere, they are float, and basically they won't do anything. So let's generate the project now. Yes, and yes. Okay, the project is generated. Before going forward, I want to go back, and now I want to configure the pins. So when you're working on a custom board, basically you are working like this. So there is no pin assignment, and you need to assign the pins yourself. Okay. So now I'm going forward, and I will choose the pins. But wait a moment, I forgot which pins were the LEDs. So now we need to look on the datasheet of this board to find out about the pins, and that's very important in our tutorials because we need to work with the datasheets when we are working with the STM32 microcontrollers. Okay, so I open my Edge and I will search for STM32 F407 disk 1, and then I'll just go to download data brief or datasheet, and then I'll open it. There should be, or basically, okay, so I think it's in reference manual. So I search again for STM32F407, then just going forward to this one. It said new order, replace blah blah blah. then we go for most probably, okay, not this one, discovery kit. Okay, user manual. So I think it should be this one. Yeah. So let's search for LEDs. Okay, so LEDs are here, and then LD1 is blah 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 user LEDs. So we need user LEDs. Okay, so it's saying that user LED3 orange, it's connected to PD13. So let's go here and then just let's choose PD13 as output, and then go back PD12, PD12, 14 and 15. Okay, so I'll go back 12 and 15. Okay, so these are the pins, and now just the pin numbers. Okay, sorry, the pin the color of the LEDs. So PD, let me just put it here maybe. Okay, so PD15 will be the blue LED. So I'll click here and I enter user label. Okay, so I enter PD15, the blue LED. Or I can write like this, LED blue. And then PD14 is red LED. LED red. Okay, I'll just pause here for a moment. Okay, let's continue to PD13. PD13 will be orange, and the last one, so this would be LED orange, and the last one will be LED green. Okay, so just checking again. Yeah, LED green. Okay, so that's the pins and the name that we assign to them, but you don't need to assign the pin names basically. But let's go forward. You will see where I use this naming and labeling. Okay, so let's save our project. Let's generate the code. Okay, perfect. Now let's go through the lines of the codes. So we have a header definition, and if we go through this, you see that it includes the HAL libraries, and basically HAL libraries are the library that we call them hardware abstraction layer, and basically they are a layer over the low level control of the microcontrollers. In microcontrollers, you are basically working with registers and uh, like a lot of 0 and 1s in some registers. So working with those registers are not always like as easy as it seems. So this HAL library will provide you some, let's say, closer to human level function, so that you don't need to be worried about that 0 and 1s in the microcontroller configuration. So you basically write a function, for example, let's say HAL underline GPIO toggle pin, and it will toggle the pin for you. So you're not worried about the bits and the 0 and 1 and all the registers that are in the hardware. So that's what exactly HAL is doing. So we have the HAL include here. Then we have some pin names, and the important one for us is this part. So as you're probably familiar with short define in C or C++, it basically assign a name for another, let's say, variable or another, let's say, object in our code. So here, GPIO pin 12 is basically a number defined in our uh, hardware GPIO, and then we just change that 12 to LED green, because when you want to work with the pins, it would be easier to just call the pins by the name that is familiar with to us, not just by calling for example 12. Although you can use any of them. I mean, you can use any sort of the coding that works for you. So now let's go back to the code. Then let's go to the main. We have some definition here that I will tell you. So we have the HAL initialization, which is like a certain function that are basically needed for the HAL to be able to work. So for example, it activate the tick timer, which is the basis for any delays in your code. Okay, so there are some certain things that need to be configured for the HAL to start working properly. So that will be done in this one. And then we have system clock configuration, which we didn't talk about it yet. So the system clock will be configured here. And then we have the GPIO initialization. So in GPIO initialization, what you will see is that there are some lines of the code that they will basically activate um, the GPIO clock. So why we need this line of the code and why it's not always connected from the beginning? Basically, connecting a clock to a peripheral basically activate that peripheral, and by activating that, that will start to consume energy. So everything is in off state by default, and you need to activate anything that you want to use. Okay, so here they activate the line, the clock peripherals, and here there are some configuration for the pins that they are related to this board basically, and you don't need to be worried about it. Then we go for our LED configuration part. Okay, so here you can see that the code, uh, basically we have two structures for GPIOs, and then you just assign the pins that you want to set up. And here, for example, it assigned the LED green, LED orange, LED red, and LED blue, and also audio. And then audio, because probably audio is on the same port as LEDs, so that's why we have it in same uh, structure. And then it configured all of them as push pulls, and then we don't have any pull up or pull down, and the frequency low, we can change that if you want. And then GPIO init, so basically it initialized the GPIO that we wanted. So it initialized all the LED green, LED orange, LED red, LED blue, and all the RST pin to push pull, and then no pull up, no pull down, and with the frequency of low, and then it will initialize it for us, and it will be ready to be used by us. So that's the line of the code. And now let's go back to our main. So here was our main, and here in main we have a while one. So what is the usage of while one? So if you don't have, if you didn't have the while one here, what happens is that microcontroller start to run the main function. It will initialize the HAL. It will activate the clocks. It will activate the GPIOs, and then boom, it's the end of the code. So nothing will be run after that. So we will put this while here, and it will be while one, which means a while or a loop that is always true. It means that it will run like for always, as long as the microcontroller is on and there is no error happen so far. So that's the usage of while one, and we can basically remove it, and you will see that the microcontroller will stop working after running this code. So we will put this while here to just keep the microcontroller from finishing the task. So we'll put some task here for it to run as long as the microcontroller is on. And I think I already told you about the user code parts. So basically you need to enter your code between the user code begin block and user code end. So your code should be here. If you enter any code here, after regenerating the project, for example, changing a GPIO, adding something, removing something, you can lose the code that are outside of the user code begin and user code end. So you need to enter your code always in this place. Okay, so we have the private type definition here, private defines, and everything that you want to use. So we at the moment we are just working with GPIO, so we don't need to be worried about that. So now let's start writing our first code. So we have a couple of functions here. So HAL GPIO will bring those functions. So we have the initialization, and then external interrupt, which we are not going through it now. And then we have read pin, toggle pin, write pin. These are the three most important functions for us. So let's start with the toggle pin. So toggle pin will change the state of the pin uh, uh, so that it would be exactly opposite of the one that it was before. So if it was 1 before running this line of code, if you run this line of code, it will change to 0. And if it was 0, it will change to 1. So that's how toggling work. So let's write the LED blue. Okay, so press Control space will bring you the list of suggestions. So we want a GPIO port, and then if you remember, it was on port D, and then port D12 pin. Okay, so it would be just let me show you. So GPIO port is defined in main.h, and it's equivalent to GPIO D, and then LED blue is defined also here in the main.h, and it's equivalent to 15. Okay, so that way we are toggling the pin. And if you remember from the first line of the code tutorials, if you run this code on your microcontroller, you should see a constant on or off based on the configuration of your microcontroller. So let's run this line of code. So I connect my board. Okay, it's connected, and now I just simply press this button here. It will build the project for me. Perfect, it's finished building, and now it will show up the edit configuration, and you just simply press OK here because everything is already configured by the CubeMX, and then it will be run on your board. After a couple of seconds, and after seeing this download verified successfully, you should be able to see your board LED. It's either always on or always off, but most probably it will be always on because you like if you followed my video, we didn't change any default configuration of the LED pin, and it means that first thing you will see is the uh, uh, pin on, and yeah, that will stay. So what happened here is that our code in this loop is running super fast. Okay, so it's toggling, but the thing is that as it's running so fast, you're not seeing it toggling, so you're seeing a constant on or off. Okay, so in order to be able to see this toggling, we need to tell the microcontroller to toggle, wait, and then toggle and wait. So this way you can see it's toggling. So let's add line of code here. HAL delay, and then let's add 100 millisecond delay here. So if you run save first, don't forget that you always need to save your project first and then click run. And now, after receiving this download verified successfully, you should be able to see your board is blinking. Okay, the LED on your board is blinking. And I'm just recording that. Okay, so that was the first thing. Okay, now let's copy and paste this and add the other LEDs to the code. So let's start with LED orange. Okay, you remember that I told you you can just simply let me add this here. You can just simply write your LED orange GPIO port here, or alternatively, you can just simply use this, and instead of writing LED orange, you can just write GPIO sorry, GPIO and then GPIO pin, what was it? 14, no, sorry, 13. So 13. These two lines are equivalent, and we just label the pins so that it would be easier for us. After a while, when you're working with your board, you just forget which one was the orange, which one was the blue. So you need to go and check everything again. So that's why we just change no, change is not the right word here. So we just assign another name to the pin so we can reference it later easier. Okay, so these two lines are similar, but just, yeah, just that. So then add red. I think we write it like that. Yeah, then red, then green, then green. Okay, so this will be our code. Yeah, that's what you should be able to see on your board. Okay, perfect. Let's go forward with reading a pin. Okay, so let's go back to the datasheet and let's see what push buttons are available on the board. So we have B1 user. It's connected to PA0. Okay, so let's go and check the configuration. PA0 is here and it's connected to push button, the blue push button on your board. Okay, so let's write a line of code here. Let's comment these codes. Okay, so they are commented now. Let's write if HAL read. Okay, so if GPIO read pin was, okay, we can enter B1 here, or we can write GPIO-A and then here GPIO pin 0. So that would be equivalent to B1 name that we had. Okay, so if it was 1, but we are not sure, if we press it, would it be 1 or 0? It depends on the configuration of the board and electronic component on the board. So we should check that in the datasheet. Are connected to the, so it's not clear here, but we can check the configuration of the pin. Okay, so if, okay, it's okay. So they connected to external interrupt. We are not going to external interrupt definitions now, so let's just put it on GPIO input at the moment, and then we should check if this pin is activated by 0 or 1, which means that if we press this button, do we receive 1 or 0 on the pin. So for that, we need to check the schematic of this board. Okay, so let's see if we have the schematic somewhere. Let's search for button. Okay, it's not. So it's not explained anywhere. Okay, now we need to check something. So STM32, oh, we have it open here. And then we should check for design. See if cat resources. Okay, so then we will check for the latest version. So our board is this one, blah blah blah. So I'm checking on the board basically now. Do we have D01? Yeah. So on the back of my board there is a tag which is written MB997D-01. So it would be this one, but probably they are same, so they should be almost same. Now let's search for PA1 or PA0. Okay, PA0. Okay, so PA0 is pulled up. Okay, it's not. This is the PA0 of the. Sorry, that was the ST-Link microcontroller, but we want the PA0 of our board. Okay, let's find it out. Button, let's search button. It's here, yeah. So user and wake up button. So what you are seeing here is that this button is one side of this button is connected to VDD, okay, which is 1, and the other side is connected to PA0, okay. So that's the microcontroller pin, okay. So when we press this button, basically what is happening is that we connect this VDD to this pin here, which finally goes from here to here to here to here and to the pin. So when we press this button, we basically connect 1. And when we release the button, because of this pull down resistor here, the 0 value will replace whatever we had here. So just I'm going through it again. So when we press this button, 1 from here will go through this line, and when we release this button, there would be a floating state here which will be override by 0 value here. So if we press button, we receive 1. If we release the button, we will receive 0. So that's what we needed so far. So let's go to our code and write that. Okay, so my assumption was right. So if GPIO A 0 was 1, then just simply GPIO toggle LED red GPIO port, LED red, pin. Okay, so and also we will put a delay here. So what happened here is that if we press and keep pushing the pin or the button, sorry, it will run this line of code. So this line of code is basically toggling the red LED. So if we press that button, the LED should blink and toggle. And if we release that button, it should stop, whether it's in on or off mode. It should just start there. So stop there. So let's run the code. I'm running the code. Okay, and now let's test it. So let me put the board. Okay, so if I press the button, it will start blinking, and if I release it, it will stop blinking. It can be whether in on or off state. Okay, so that's how it works, and that was the basic of reading a pin. Okay, so yeah, that was the GPIO, and very briefly uh, going through using the read pin, toggle pin. Okay, okay, now we have also two other functions that are important. So let's change this line of code in a way that if we press the button, the LED red stay on, and whenever we took our hand, it should turn the LED off. Okay, so we don't want the toggle anymore, so we just want on or off. Okay, so in order to do that, we have a function called GPIO write pin. So we say LED red GPIO LED red pin. Okay, and then we say the state that we wanted. So we want the GPIO in the set mode. Set means 1, reset means 0. So we wanted to set. So we wanted to be on. And we write a else here, and then we just simply copy this line. And we say reset. So it means that if we press that button, it will set the LED, and if we release that button, which means that button, like reading the button pin, will be 0, and that will activate this else. So that will turn off the LED. Okay, so that's another usage and another function. So let's run this line of code. Okay, now let's try it. So when I press this button, it will turn on the LED, and when I release it, it will turn off the LED. Okay, so that was it for the GPIO. So basically that was a very short introduction to GPIOs, and then GPIO toggling, GPIO reading, and GPIO writing. So that was it, and see you in another tutorial.